Good day everyone, this is Norman Oppus from Oppus 1-1. Today we will perform an experiment about laws of reflection. What is reflection? There are two kinds of reflection, the spectacular reflection and the diffuse reflection. Spectacular reflection, when rays are reflected from a smooth surface, the reflected image is formed a clear image and has a single direction, while the diffuse reflection, when rays reflected from a rough surface, the reflection reflected into different directions and doesn't form any clear image. By the way, what is laws of reflection? There are three laws of reflection. First, the angle between the ray and the normal is equal to the angle between the incident ray and normal. By the way, we use mirror here. The mirror is in vertical position. Then we put ruler here. It is our normal line. So in the first law, we will explain how the first law, this one, the inverted, the angle of incidence is equal to the angle of reflection. Like for example, this one, the angle of incidence is 45 degrees. The angle of reflection also 45 degrees. Like for example, the angle of the angle of incidence is increases, the angle of reflection also increases. The next, uh, the incident ray, the normal line, and the reflected ray are all in same plane. This one example. By the way, what is incident ray and reflected rays? Incident rays, this one is the incident rays. The light from the source to the mirror, this one is the incident rays. And the reflected rays from the mirror going into one direction, this one is the reflected rays. So in the second law, the incident ray should be in our example, the incident ray are in horizontal plane, and the reflected ray also in horizontal plane, and the normal plane here is also horizontal. That's why the three are in same plane. Then last, uh, the incident ray is in one direction, and sorry, in one side, and the reflective ray also in the other side. This side is for the incident ray, and this one for the reflective ray. This one is incident ray, this one is the reflected ray. Uh, Take note that the incident ray and the reflected ray doesn't come along in one direction. It should be on different sides. This one is the normal line. The incident ray in one side, and the reflected ray on the other side, and that's for the three laws of reflection. In my experiment now, I use four mirrors. First mirror, second mirror, third mirror, and last is the fourth mirror. If you have noticed, the position of the four mirrors are in clock position. First mirror is 3 o'clock, second mirror 12 o'clock, third mirror is in 9 o'clock, and the fourth mirror in the 6 o'clock. What's the purpose behind this position? The purpose is, in the first mirror, we can apply the three laws of reflection. Because on the second mirror, same thing, we can apply the three laws of reflection also in the third mirror and in the fourth mirror. But the difference is one. On the second mirror, the incident ray from the reflective ray of first mirror, it will become the incident ray in the second mirror. Same thing in the third mirror, the reflective ray from the second mirror going on to third mirror, the reflective ray will become incident ray. Same thing with the third mirror going to the fourth mirror, the reflective ray will become the incident ray. Then the angle, the degrees is the same, 45 degrees, 45 degrees, 45 degrees, and an example. Now I have a trick. In the fourth mirror, if you see, there is a letter CK here in the mirror. What if the third mirror hits the light on the fourth mirror, is it possible that the letter CK will change, or it is written invertedly? If your answer is inverted, then you're correct. Okay, I will show you. Okay, the angle of the, now we will change the angle of the fourth mirror. Okay, if you have noticed what happened on the CK, so the degrees of the mirror is 45 degrees. The letter CK written invertedly. So what I will do so that the letter CK will remain in normal position, we'll do that we will use another mirror. So since the first mirror in on 3 o'clock, then we will put the fourth mirror in normal position in 6 o'clock. Then the reflection ray from the third mirror will hit on the fourth mirror, and let's see what happens. Okay, the CK letter written in normal reading position. Okay, that's all for the laws of reflection. Now I have example. If you have noticed the word letter written in the ambulance in front, I have here some examples. If you have noticed, the ambulance rated invertedly in front of the vehicle, and I have also the normal reading position of the ambulance. What is the purpose behind this written? But why is it that the word invertedly written? I have a scenario. For example, I'm driving a car. Then this mirror is my side mirror. Then behind my car there is a ambulance. Let's see what happened on the inverted letter. If I see the ambulance, the written word in front. So now if I see the side mirror, now it is readable. So because of the side mirror, the inverted will now into normal reading position. Like for example, if the word ambulance written in normal reading position, so what would happen if I saw this on the side mirror? Let's see. Now, if I see the side mirror, the word ambulance become not readable, or it is written invertedly. That's the reason why the ambulance, the word ambulance written invertedly in front of the vehicle. Another example, since I am a optometry student, I will show you an example. This one, this two is a Snellen chart from normal reading Snellen chart and the inverted Snellen chart. Snellen chart, it is used for visual acuity test for the patient. If we use this Snellen chart, the normal distance from the Snellen chart to the patient at 20 feet or 6 degrees. So like for example, there is a scenario in a clinic, the space is limited. Like for example, the clinic cannot accommodate 6 meters. So some optometrists, they use the inverted Snellen chart. This one, it is the inverted Snellen chart. So how can do this? We can do this by the aid of mirror. So here we go. What we will do is this one. Like for example, the clinic accommodate only 3 meters. So for example, this one here, the patient and the mirror, the distance between them, between the two is 3 meters. So we will put the inverted Snellen chart in front of the mirror. So let's see what happens. If you see the mirror, the inverted Snellen chart now become in normal reading position. So the patient can now read what the letters written on the inverted Snellen chart. So here, from the patient to the mirror 3 meters, then from the mirror to the inverted Snellen chart 3 meters. So the total is 6 meters. That is the normal distance in checking for the visual acuity test. That's the purpose why there is an inverted Snellen chart. This is usually used for the clinics who have limited space. That's two are my examples on the reflection, and that's all for today. Thank you very much. I hope you learned something in this video. Thank you very much.